Okay, guys, let's talk about the angle bisector again. Okay, now, of course, with an angle bisector, we want to have an angle. So 3 points determine an angle, all right? And then, of course, we build that angle with either segments, rays, or lines, okay? We're going to use rays here just because officially that's what you're supposed to do with an angle. It's supposed to be constructed out of rays, okay? Now, and of course, I can name that angle, and naming that angle, I just always remember that the middle point is always the middle point that I select when I want to measure that angle. So if I want to measure this angle, okay, I have that angle. I select point A, select point B, then select point C, measure the angle, okay? So the angle is roughly 57 degrees at this point, but of course it can change. It can change, all right? Now, I want to do the angle bisector. What is the angle bisector, okay? Well, remember, the construct menu will allow us to do an angle bisector, but not until we select the points defining the angle. See, it's not highlighted. So we need to select the points in order. A, select A. Make sure you select B as the second point, and then C, okay? Or you could select CBA, but B has got to be the middle point that you select, okay? Construct the angle bisector right here, okay? And we're just going to put a point on there, of course, which is going to be able to move around, and we're going to label that point. And so now what we do is you should see that the two new angles formed, of course, are adjacent because they share the common vertex B, and they share the common ray BD, but they're also congruent, okay? They're also congruent. So, of course, we'll measure that. And so to measure that, we'll say select point A, B, D, A, B, D, and measure its angle, okay? Measure the angle there. All right, measure the angle DBC, DBC, measure that angle. That should be the same as ABD. Measure that angle, sure it's the same, okay? And the nice thing here about Sketchpad is regardless of how I change this angle, okay? Regardless of how I change that angle, these two angles remain the same. So in other words, okay, they should be in a 1-to-1 ratio. So in other words, if I go to number, calculate, and I say compare ABD to divided by DBC, they always are in a 1-to-1 ratio, 1-to-1 ratio, okay? That's the angle bisector, all right? They're always going to be equal, so which means their ratio is always going to be 1-to-1. Now, how does it compare with the original angle? Okay, well, certainly we have angle addition. Certainly we have angle addition. Number, calculate, you know, this angle plus the other angle will always equal the full angle, okay? So we certainly can see that regardless of how I change that, okay? That full angle is always the sum of these, which are both equal, okay? The other thing, if we want to look at a ratio, is that the ratio of ABD to the whole angle is going to be 1-to-2. In other words, the whole angle is twice the measure of the ABD. And of course, we can show that, calculate, number calculate, one of the small angles divided by the all-inclusive angle is always going to be a 1-to-2 ratio, okay? It's always going to be a 1-to-2 ratio, which of course is 0.5, okay? And that's going to remain the same. Maybe another way of looking at that is to say it's the large angle divided by the small angle is always going to be in a 2-to-1 ratio, okay? Always going to be in a 2-to-1 ratio. So that, again, regardless of how I change that, those ratios remain consistent. And that's what we mean by ratios, okay? Even though the values that we're comparing in the ratio are subject to change, their quotient, that is, when we divide one by the other, they remain fixed, okay? And that's, so with an angle bisector, okay, what do we have to remember? Okay, it is a ray containing the vertex of an angle, which splits the angle into two congruent adjacent angles. Two congruent adjacent angles. A number of things happen. We get two equal angles. That's what we mean by congruent. Okay. We also have the sum of the two equaling the whole by angle addition. And then we have the ratio of the two new angles to one another being 1 to 1, or the ratio of the original angle to the newly formed angle is going to be 2 to 1, or the ratio of the newly formed angle to the original angle is going to be 1 to 2 or 0.5. Okay? So some things we're going to be back with another demonstration on this in just one. Well, let's just do it now. Okay? So here's another nice kind of neat thing that you can do with angle bisectors. Okay? So I'm going to just pull up another page here. Now, we should remember that any 3 points we had a circle that went around it. We called it the circumscribed circle. Okay, and we knew that the circumscribed circle, we had to find the perpendicular bisectors of the sides. Now, what I want to do is I want to find what's called the inscribed circle. So that is, I want to go and find the circle which just sits inside of this triangle, or any triangle for that matter. And that is by constructing the angle bisectors. Constructing the angle bisectors. And we'll see that the angle bisectors all meet at one point. So I'm going to select each of the angles. A, B, C. That's selecting angle B. Going to construct the angle bisector. Okay. Going to select angle C by selecting point B, C, and A. Okay. And I'm going to construct the angle bisector there. And actually, the two of them is sufficient, but we will just show that angle A. How I select angle A, select B, A, C, construct angle bisector, and we will see that that point is, okay, going in now, that point is where all the angle bisectors meet. Okay, and of course, you know, that point might change as I change the triangle, but what isn't going to change is this. That's the center of the circle that sits right inside here. Okay, that's the center of the circle that sits right inside. All right, and that's called the inscribed circle. So we're going to make it known right now. The center of the inscribed circle is the point of intersection of the angle bisectors. And we talked about the circumscribed circle. That's the circle going around containing A, B, and C. The inscribed circle is the circle that sits right inside of the triangle. And what we say is where the triangle and the circle touch is what we call a point of tangency, okay? But they only touch at one point, okay? So that is what we call the inscribed circle, okay? So a little something new that you might end up exploring on Sketchpad.